Hi, hello. Welcome to Tea Time with TRA Tocklai. In today's episode, we'll talk about Geographic Information Systems, collectively known as Geoinformatics. To talk about this, I have invited Mr. Kusumbar Bodolai, who has been working with Dr. Rupanjali in the Division of Climate Change. Welcome, Mr. Kusumbar.
It's a pleasure to be here today, sir.
All right. We are equally happy to talk to you about Geographic Information Systems. Because many planters are talking about it nowadays. In fact, they are voluntarily asking about what kind of system we can offer it to them. So, but before getting into that, we will start from the scratch. What is it all about, the Geographic Information Systems? Can you throw some light?
Yes, sir. Geoinformatics is an umbrella term. It consists of mainly three tools. One is GIS, Geographic Information System. One is remote sensing. One is Global Navigation Satellite System, which is GNSS. So when we talk about GIS, Geographic Information System, it's a computer-based system. It capture, store, manipulate, or analyze and visualize geospatial data. So when we talk about tea plantation management, it basically the GIS basically deals with the sectional data, then drainage system, and all the assets those are available in the tea garden. Now coming to remote sensing part. Remote sensing is a science and technology to obtain information about any object or phenomena on the earth surface without having the physical contact. Now we can tell it as like our eyes in the sky, like the satellites, drones, they continuously monitor the tea plantation as well as different biotic as well as abiotic stresses. Now when we come to the global navigation system, it basically provides us the accurate positioning. Now GNSS or Global Navigation Satellite System is basically, it's a satellite based system. So it provides PNT service, basically positioning, navigation as well as time. Now it basically allows to capture the accurate latitude, longitude, elevation as well as time.
Scientifically, it is okay to understand what you are talking about. But when it comes to practical purpose, what kind of gap it is going to fill?
Generally, the traditional surveying techniques takes time. Now, when we use geoinformatics, basically it will reduce the time that will generally required for the surveying, as well as it will give you the database, which is basically helpful for decision making as well as spatial analysis.
Yeah. So this can be used in the precision agriculture.
Yes, sir.
As a tool.
Yes, sir.
So what do you think about precision agriculture, and what do you think it can save for us?
Sir, when we talk about precision agriculture, it basically moving away from the blanket treatment. Suppose we have a big tea garden or tea plantation area. Now, instead of spraying required chemicals to the entire division, we can select the hotspots where we need immediate attention. And that way we can reduce the cost of the chemicals. We can reduce, we can reduce the manpower, and also it will help to sustainable practices.
So in a way that it can also help us in fine-tuning the labor utilization in the fields?
Yes, sir. It can.
It can utilize because you were sensing it remotely about all the things that's happening in the plantation.
Yes, sir.
How do you think it will help us in labor deployment?
Okay, sir, in terms of labor deployment, geoinformatics can help. It can provide the data-driven task assignment. One is route optimization. One is called, sir, monitoring and performance tracking. One is, sir, resource allocation and integrated planning. So all the 4-5 components, it can be done using Geographic Information System.
Based on the data collected?
Yes, sir.
So this is going to give you an opportunity area that where you can optimize the labor utilization, and thereby it is going to save the labor cost.
Yes, sir. The cost as well as the time.
The time, okay. And it can also do something with shade tree management?
Yes, sir, it can be done because, sir, in using remote sensing data, sometimes it is difficult to count the tree numbers. But when we use drone data, UAV data, then we'll get very high resolution images. So based on that image, we can automatically calculate the total numbers of shade tree, the canopy cover, and that way it will help you in the shade management part also. We know for efficient plantation, we need around 40-60% of shade with the help of shade trees. Now suppose if one section is, the shade is very limited, or we need immediate intervention, or we need to plant some shade trees there. So that in this regard, we can help using the remote sensing tools and GIS application.
When you talk about drones here, what kind of drones you are referring to?
Sir, I am referring to the multispectral drone as well as hyperspectral drone, since it is related to the agricultural activities.
Yeah, but this is over and above your remote sensing, and also the over and above the GIS information which you will take it from the satellite.
Yes, sir. It actually comes under the remote sensing part.
Remote sensing.
Yeah.
So it's over and above that.
Yes,
you will also have to fly some drones in the garden.
Yes, sir.
Okay. Who will be the custodian of drones? Who will be flying it over the garden?
Sir, it is not necessary the tea garden should have their own drones. They can hire the drone from the third parties. There are multiple players in the market nowadays. They capture the data as and when required, and they will definitely charge it on the basis of the area that will cover.
And you are sure about the data integrity, particularly the data generated in a garden, the person who is renting the drone will not be using it in another garden, right?
Actually, they can sign some MOUs, and based on the agreement, they can definitely allow them to fly the drones in their garden.
Yeah. Since we are talking about remote sensing and related stuff, can we also do some kind of flood management through these machines?
Yes, sir, it is important because when we talk about Northeast India, Brahmaputra and floodplain plays a dominant role in Northeast India in terms of fluvial activities. The high precipitation during the monsoon season actually leads to the high flooding in the particular region.
Yeah.
Now,
and also shifting of river, right?
Exactly.
It happens like shifting from this side to that side.
So using a remote sensing technique, we can quantify the shifting pattern. Suppose now for Northeast India, we have the remote sensing data from 1970s onwards. So more than 50 years data we have. Suppose we are quantifying that shift from 30 to 40 years. That way we can understand the behavior of any stream or any tributary or the main river Brahmaputra in near the tea garden area.
Now, and we can predict based on our experience of 30 years data?
Yes, sir. We can predict. There are multiple models are available. Based on the modeling, we can predict what will be the scenario after 10 years, after 15 years.
Okay. So using this model, using these tools, can you also model what will happen in 2030, 2035? What will happen to our drain systems? Is there anything possible to model it?
Yes, sir, it is possible. This is where science gets predictive. So we have multiple global climate models. So these are mathematical models based on, it basically simulate Earth climate in a global scale. Now, along with global climate model, we have shared socioeconomic pathways. So there are multiple shared socioeconomic pathways. One, mainly 5. One is shared socioeconomic pathway 1.9. One is shared socioeconomic pathway SSP 1, 2.6, then 4.5, 7, and 8.0. So these are some effective radiative forcing, and these are some scenarios. Suppose we use shared socioeconomic pathway 4.5. It basically saying that in 2100, the temperature will increase around 2.7 degrees Celsius.
Oh. Average temperature.
Average temperature.
Wow.
Now, when we talk about shared socioeconomic pathway 8.5, this is worst case scenario. Suppose the fossil fuel consumption is maximum. There you will see the increase of temperature around 4.4 degrees Celsius. So based on that, we can predict what will be the scenario in 2030, 2040, 2070, or 2100.
That makes sense. See, if it is 4.4 in reality, at the average temperature, we can forget about tea.
Yes.
Honestly, we can forget. I mean, teas will come, but then the struggle which you are going to take to maintain a tea garden, is going to be enormous. So it makes sense to me to listen to these models. So ultimately, what is needed is mitigation of carbon emission that is needed by planters themselves, without waiting for somebody's support. It is our own garden, so we need to put in our own efforts in a micro environment. What kind of what kind of mitigation strategies we can follow that they are supposed to follow.
Yes, sir.
It's good. Move on to the other area of science-based applications. For example, soil monitoring and soil fertility monitoring. These are all possible using this remote sensing and GIS. Can you throw some light on that?
Yes, sir. Actually, GIS cannot replace the traditional, testing methodologies in terms of soil.
That's very
so basically, it helps to work smarter. For example, suppose we are collecting soil sample more than 20, 30 or 50 samples per hectare for a particular tea estate, which is around 500 hectare of land. Now, it's a time consuming process. Also, it's a labor intensive work. Now, how GIS could be helpful? Because instead of taking 50 samples, we can reduce the number to 10 and we can do some geostatistical algorithms.
Based on what you are reducing?
So, actually, instead of collecting the samples from entire section, we can categorize different layers. For example, the common elevation, common soil type, common topography, common vegetation. Based on that, we can collect the data, we can reduce the samples, and after that, we can apply some geostatistical algorithms like kriging, and we can interpolate the data. So basically, based on the different vegetation type, the soil pattern, it will predict the data. So we are reducing the number. So we are reducing the number and predict. We can predict the different soil characteristics like soil pH, soil phosphorus, all the parameters.
But sometimes I'm getting understanding that from some private parties or from the garden side, I'm getting an understanding that people come around and then talk to them about forget about conventional methods of analysis. We can map it everything through satellite and geographic systems, and we can even estimate what is the soil organic carbon and this and that. All those things are happening around. I'm not against science. I'm a scientist myself. But then when these kind of big bombs are dropped, which are false or which are not having scientific basis, then it is really difficult to counter argue with them. What is your take on that?
So basically, if we want to explore the definition part of remote sensing, basically it says that it's a acquisition of data without having the physical contact. But to validate the data, we need the actual ground information.
Correct.
In this regard, no one can replace the traditional testing methodologies, because yes, we can reduce the number of samples,
and also we can use them in a wiser way. Like
yes,
you can put them in a system. You can collate the data, and then you can try to take the output whatever the way you want.
Yes,
that is what it's going to be very useful.
Yes,
it's good that you are at least indicating that it is not a replacement for traditional method of collecting data.
No, it's not the replacement. It's a work smarter.
Yeah, it's very good. Let's move slightly towards carbon management, particularly with respect to carbon neutralization. How GIS can help us?
In terms of quantifying carbon storage, we can use Geographic Information System and remote sensing, and also GNSS service. So altogether, we can say we can use
Geoinformatics.
We have the experience to work in Upper Assam area. So where we collected the data directly from the field, we calculate the T-guard, we calculated the above ground biomass, below ground biomass, soil organic carbon, and all the data we integrate in the GIS platform. It's a good result. It is under publication, sir. We are working on it actually. So it gives us a promising result. So we can quantify the carbon storage, and after that we can quantify what is the carbon dioxide equivalent stored in that particular section of the garden or in the entire garden. So that way we can help.
But when you talk about what is above the ground and below the ground, how do you measure it?
We collected the data. In person, we visited the garden. We measured the girth of the tree, and also the different species, shade tree species, and based on some equations, we calculated the below ground biomass. So it is not using the remote sensing, it is using some traditional method.
Traditional method, but is it using destructive method, like you
No.
uproot and then
No,
do?
it was not destructive method.
It is not destructive. So any garden can afford to do that.
Yes, sir, they can do.
Yeah, that's what the point I wanted to bring out. Genetic diversity is other important aspects nowadays we are all afraid of. Personally, I feel that we are losing the genetic diversity which was existing 100 years before. So, what way this geographic information systems or geoinformatics can help to reduce loss of genetic diversity?
Okay, sir. Sir, actually, in terms of genetic diversity mapping or germplasm collection, so one department in our TRA, plant breeding department, they have been working on it. But the main part we can collaborate is like we can integrate the geotagging component here.
Yeah.
Suppose we take the location of one cultivars, suppose X, and we can take, based on the location, we can find out what is the climatic condition that was available in last 100 years or last 50 years or last 100 years. And based on that germplasm inventory we can develop.
By generating germplasm inventory, we can try to prevent some old jarts and then old varieties.
Definitely, sir. Yes.
Already we talked about the drone. Now when we talk about drone versus satellite, when to use, what to use? Okay.
Sir, suppose we have a very large area, then definitely, or we want to continuously monitor different status like the health condition of the tea plants and all. So definitely we should prefer for the satellite. Suppose using the satellite data, we identify some hotspots where some intervention is required. So there we can, for that particular section, we can utilize drones, because it will give you very high resolution data, suppose 2 meter to 5 centimeter, 2 centimeter to 5 centimeter data. Yeah. And based on data, we can take the, immediate action. We can, whether some, spraying is required or other measures needs to be taken. So in that regard, actually, we use drone.
Okay, but when you start collecting this data from remote sensing satellite or from drone, over the period of time, it is going to accumulate more and more.
Yes, sir.
How do we effectively manage it? Do you have software attached to that? See, when you collect data from these two portals, these two techniques, you are going to accumulate large number of data every year.
Yes, sir.
How will you drive conclusion out of it?
Basically, sir, suppose we are, acquiring the raw data, and based on the raw data, we will use it, we will develop some indices. We can generate some indices. This will definitely reduce the volume of the data. So okay. Suppose we are extracting the main information, we can eliminate, we can delete the raw information.
Is there any way that the remote sensing technique can help us to market our tea?
One concept like blockchain traceability comes into picture here. Because suppose one buyer in London or in Tokyo, they can directly scan the QR code that is on the tea package, and they can find out what is the status of carbon footprint, what is the status of the chemical that was used during the processing part, and they can get to know everything. So if now this particular process comes into the market nowadays, this blockchain traceability, and integration of blockchain with the tea products, so definitely increase the value in the market.
Yeah, true. It enhances the customer experience.
Yes,
you know, customer is happy with the data provided about where the tea is coming from. But what kind of data it can give? The QR code, when we talk about it, what kind of data can be attached to that? Up to garden level?
Yes, sir. Up to garden level. By scanning the QR code, one map will be open, like one Google map will open.
Yeah.
And then based on, they can find out from which section actually this particular, tea was plucked.
Okay. That's quite interesting. How about factory related operation with GIS? Anything is being done?
Yes, sir. Mainly, sir, route optimization, or, as I have already mentioned, in terms of labor deployment and all. So they can, assign some tasks to the particular workforce. So based on that, they can, monitor whether the assigned task was completed or not. So in terms of factory also, they can choose the optimal path for the raw materials as well as for the outputs. so they can use this optimal route path and other management aspect also. And also one of the most important thing, like for the resource management, other tools with the other available resource management tools, so GIS data could be integrated.
Okay.
So that is one of the most important facility available in GIS.
And when it comes to drought management and flooding management, as you have been also pointing out, that can also be mapped directly, and then it can give alarm to the planters before the drought is setting in, and also it can also alarm the planters before the flooding is going to happen. Means nearing the drought season, the system can alarm them that drought is going to come. So these are all the areas to be focused. Such information can be fed into that and then retrieved on time accurately, right? That is also
Yes,
possible.
Sir. It can be done, sir. Yeah. Using remote sensing techniques, we can gather information regarding the drought conditions, like possible drought condition in my tea plantation area. Yeah. And also, like starting from the groundwater level, also we can extract information. Suppose we have the primary data of the bore wells, then we can map the entire groundwater that is available within that particular area, and based on that, whether the irrigation is required or not, and how the water will be available, how long it will be available in the tea plantation area could be mapped.
Yeah, water availability, and also the areas requiring irrigation because of the drought or because of the facing towards the sun, that can be mapped, and then the irrigation can be started every time there. Yeah, those are all the benefits, I suppose.
Yes,
using
sir.
GIS.
Sir, I just want to add one point, one database. This is digital elevation model. So based on the digital elevation model, we can plan entire drainage system or entire basin level drainage system in a particular region. Now, this digital elevation model could be helpful for the water management, as well as to improve the microclimatic condition is required within the tea plantation area could be done.
That's good. Yeah. Similarly, whether this will be useful to understand a new clearing area suitable for tea cultivation or not?
Yes, sir, it can be done, because once we have the database, once we have the entire soil database, entire sectional database, and the available cultivars in my tea garden, then I can do the site suitability of whether the new section or new area could be suitable for new plantation or not. And also we can integrate the future climatic scenario as well. Suppose what will be the scenario in 2050, and whether it is a flood prone area or erosion prone area or not. If it is not, then we can go for plantation. So site suitability also can be analyzed using the geoinformatics tools.
Yeah. Similarly, intercropping, when we say people go for medicinal plants planting in between the tea, or they go for any other cash crop in between tea. Those things also can be mapped, looking at the vacant area, where you have the vacant area, there they can give concentration on such things.
Yes, sir. Because to plant one particular crop, we should know the conditions, those are favorable for that particular plantation or for that particular crop. Suppose we have all the information, then we can find out those conditions are available in my garden or not. If it is available, then GIS can easily highlight those areas where it will be suitable. So that way we can help.
How about people talking about digital pH meter, keeping it in gardens across the places, and digital soil moisture meter and so many other meters, and sensing information through that and driving conclusions? Is that really viable?
So yes, we can integrate those information in our GIS system, because suppose in a particular 1 hectare of area, we have 1 or 2 pH meter or other sensors. The generated data we can integrate with the GIS. Now we have the data for 2 points initially. Now integrating GIS, we can interpolate the data. We can understand what will be the scenario in entire garden. Yeah. So that way it can be helpful.
Okay. How about people going into ready-made tools available online like Google Earth Pro and other things? Just use it as a technology for mapping tea garden fertility or tea garden problems. What is your take on that?
Okay, so actually when we talk about Google Earth Pro, it's a platform. So nowadays it is widely used, but I think only for the visualization purpose, that is fine. But if you want some scientific conclusion, then definitely some dedicated tools. It may be open source or it may be paid, dedicated tools are required to understand the result. Suppose the Google Earth Pro basically uses the third-party satellite data. Instead of using the third-party satellite data from one platform, we can directly download the data. We can access direct satellite data, and we can analyze it through dedicated softwares.
Whether TRA can help them to acquire satellite data?
Yes, sir. We can help them to acquire satellite data if it is required.
And also TRA can help them in monitoring, mapping, everything TRA can help in.
Yes, sir. The skill development as well as the processing, how we can process the data and required trainings and all, we can also provide that.
Do we have any experience of doing it in any garden?
Yes, sir. We have done it. My lab, Climate and GIS lab, actually, we did it for a few gardens in the past, actually.
Good. And we are ready to extrapolate to other gardens.
Definitely,
also.
Sir. Definitely.
We are talking about drones and satellites. Drones, we can understand that we can fly anytime you want, provided if you have one with multispectral camera. But when it comes to satellite, what kind of frequency you get the same imaging done?
Okay, sir, in terms of satellite data, generally we use Landsat and Sentinel. These are freely available data.
Okay.
And Landsat is from United States Geological Survey. So it will give you 30-meter resolution of the information, and the temporal resolution is around 16 days. And also when we talk about Sentinel data, it is approximately 10 days temporal resolution, means revisit time is around 10 days. These data are available for monitoring purpose. And one important fact regarding the Sentinel is the spatial resolution is around 10 meter. So we can get 10 meter resolution data freely available.
Okay. But 10 meters and 30 meters looks too large, too coarser, too thick for me. If you want to have more closer data, like a meter or less, is that possible?
Yes, sir. We have the Cartosat information, Cartosat data, which is for Indian Space Research Organization. We have, high resolution data as well from the foreign satellite. But regarding that, we have to procure the data from the site.
But it's one-time cost.
Yes, it is one-time cost. If it is feasible, then definitely we can procure it. Now,
what's the kind of money it involves when you talk about procurement? Roughly, you may not know it right.
Okay.
But
sir, from my past experience, it cost around 3,000 to 5,000 per square kilometer cost.
3,000 to 5,000 rupees
per square kilometer. But
square kilometer. Yeah, that's big.
Yeah, that is big. But actually, they used to quote the amount based on your area of interest. If you are procuring for a large area, definitely the cost will be less.
Okay.
If you are procuring for a small pocket, then the cost will be high.
But then this is one-time cost, I said. But then you will also get data only once, or you will get continuously data every time the satellite comes into your area?
No, sir. I will get the data for one day only.
Just once?
Just once. If I need, the fresh data, then definitely I'll have to procure it again.
Those are all very expensive.
Yes, sir.
Okay, so it's better to have existing map on which JAS is built with the help of TRA.
We are considering one garden which is around 300 hectare or 500 hectare.
Yeah.
So we can generate micro level data and we can integrate with the GIS ecosystem so that we can plan it accordingly.
Yeah, I'm hearing that ISRO is collaborating with NASA to provide some data to Indian farmers and Indian users. What is your opinion on that?
Yes, sir. Recently, one huge development in terms of satellite technology. One is NASA ISRO synthetic aperture radar. So this satellite is currently, it will operational soon. And some pictures I see yesterday. So it provides SAR information, synthetic aperture radar information for S and L band. So it will give you the spatial resolution around 7 meter. So it is comparatively very high resolution, we can say. And it will be definitely, as per the website, it is open access, it will be open access. So freely we will get the data.
Now, when you compare with 30 meters and 10 meters, definitely 7 meters is much higher resolution.
And also it's synthetic aperture radar data. Basically, all weather we can, do the analysis. For northeastern region, mainly the cloud cover is one of the main problem for the multispectral information. But using the radar data, SAR data, that problems will eliminate.
Okay. Suppose if you want to assess natural calamity impact in my garden, how long should I wait if I need to have remote sensing data?
So if we have the data, then definitely within few weeks we can quantify the damages. So yeah, we can do it, sir.
But with the drone, probably within a day you can quantify.
Yeah, we can capture the data
immediately.
Yeah, we can capture the data, but processing definitely will take few hours or few days. Yeah.
For drone.
For drones, processing will take times actually.
Processing time will be same for both satellite data as well as for drone data.
No, sir. Actually, basically depends on the area of interest, how big my area is, and also the drone data. Basically, it's a high resolution comparatively satellite data. So the volume of drone data is basically it's large. So it takes more time than the satellite data. Nowadays, some cloud platforms are available like Google Earth Engine. So there we can, without downloading the data, without downloading the raw data, we can process it.
How do we convince the garden managers or garden owners about using geoinformatics?
Sir, they can start from the basics. It is not required to procure everything. It is not required to procure drones. It is not required to procure the satellite data, softwares and all. They can start from the beginning, like they can generate the basic digital garden database, like entire boundary, different sections, different drainage channels.
Where do they get it from?
They can use GIS, small GIS tools like mobile-based tools, and they can generate the database. And after that, they need to identify one or two main problems, and after that, they need to work on it. And we are here in Tocklai. We can definitely help them how to process the data, how to capture the data, how to process the data, and how to develop one platform, one basic platform, so that the further analysis could be done.
That is what is most important. That's a point I was expecting from you also. So TRA can collaborate with gardens.
Definitely, sir. We can collaborate
in making geoinformatics viable in garden level.
Yes, sir.
And we will start with TRA. I mean, the gardens will start with TRA and then they can grow over the period of time.
Definitely, sir.
And once they have geoinformatics, every time when they do the soil analysis and then MATI analysis, everything can be fed into that?
Yes, sir. Once they prepare the baseline data, so all the additional attribute information could be, attached with the particular system. So they will get to know like what was there last 10 years and what will be happen. They can take the decisions. So the precision agriculture will come into picture.
Will come into the picture. When we talk about precision agriculture, then naturally they can also easily map the areas prone for pest and diseases.
Yes, sir.
Yes, and similarly the areas prone for, or the areas known for potassium deficiency, less in organic carbon, all those areas they can categorize and then put them in the map.
Definitely, sir, because GIS works in layers. Suppose I have a soil layer. So on top of it, I can place the drainage network, I can place the water bodies, I can place all the sectional details, I can place the yield data. So layer by layer, we can put all the information, and as and when required, we can play among the layers, and based on that, we can take the precise decision.
That's in fact interesting, because it is not possible for every garden owner to remember all the details of the garden, but then in the layers when it is captured, then you can retrieve the layer which you want, and accordingly you can focus on the cultivation aspects.
Definitely, sir.
Yeah, that's very good. Even though all these things are looking like very simple when we talk about online platforms, but to really do it by a planter, it's very difficult, because the planters have got their own stress about garden, about manuring, about plucking. So many things are in place for them. So for them to understand this, do we have any training program or something?
Definitely, sir. We can give the training to the people, and also we can highlight a few new advanced technologies so that they can apply in their own respective gardens. Also in the DTM course also, we are now providing the trainings to the students, because new the modern survey techniques and all. So they are currently utilizing this geoinformatics, how it will be helpful for the tea plantation area.
Yeah. Particularly in the period of shrinking labor, it will be very, very handy to use such tools to plan their operations, daily operations. That is where they may be needing a training from TRA.
Yes, sir.
Thank you very much, Mr. Kusumbar Bodolai, for coming and then explaining the advantage of using geoinformatics in tea gardens. Thank you.
Thank you, sir. Thank you so much.